All right, guys. So right now we are going to be graphing what's called a heat curve. So at the top of your graph, just go ahead and title it heat curve. Okay. Now, these graphs could look very different. The graph I'm going to show you right now is an example of water. But every substance has a unique heat curve or a unique cooling curve. But again, we're going to use water for an example. So for these curves, we have to understand what our x-axis is and what our y-axis is. So remember from math class, this is our x and this is our y. Our x-axis is going to be time, and our y-axis is going to be temperature. We could abbreviate temperature with temp. Now, we have learned that things change phases when thermal energy is added or removed. So thermal energy is another word for temperature, right? So the more thermal energy we have, the higher temperature we are going to have. So for water, we know water has three phases, right? Solid, liquid, gas. Down here, right? Down here, this direction, our temperature is lower, and our temperature is higher up here. Okay, so this is just as time goes on. So we know at lower temperatures, water is going to be turning into a solid. Okay, so right here, this line right here, currently our water is a solid. Okay, as we add thermal energy, eventually at a specific time, that solid is going to turn into a liquid. So where we see these flat spots right here, these heat curves, these flat spots are going to tell you something very, very specific. Okay, these flat spots are important. These flat spots on the graph represent a phase change. Okay, so we have solid. And we know after something goes into a solid, it goes to a liquid. So liquid's going to be right here. So then between solid and liquid, we have this phase change. That phase change is called melting. So this is going to be where melting takes place. Okay? We're going to see that melting, that water has a melting point, okay, of 0 degrees Celsius. Okay, and when it reaches 0 degrees Celsius, it's going to start changing. Let me put degree C. It's going to start changing from a solid to a liquid. Once, and you'll notice because it's going to stay that same temperature the entire time. So until the water is fully melted, all the ice is 100% gone, it's going to stay at 0 degrees Celsius. Once all of the ice is officially gone, there's 0 solid left. Then we're going to start increasing to our liquid. Then that's we're going to see the temperature start to rise. That's because the thermal energy, instead of going to heating the liquid, it's going to breaking the forces that hold the solid together. Once all those forces are gone, now the thermal energy could go into the liquid to raise the temperature of the liquid. So right here, this area right here, is when we start getting 0.1, 0.2, all the way up to, it goes 1, 2, 3, 4, 5, 6, 7, blah, 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 all the way up to our next phase change right here. Now, based on what we know about water, we know that water boils at 100 degrees Celsius. So we know that right here, this is our 100 degrees Celsius point right here. That's when water starts to evaporate, okay? And evaporation is a phase change. It goes from a liquid to a solid. So again, we have another flat spot right here. That flat spot is going to be very, very, very important because that's telling us that there's a phase change happening. This phase change right here, going from a liquid to a gas, okay, going from a liquid to a gas, that is called evaporation. Okay, and once water reaches 100 degrees, all that water in that liquid is going to stay 100 degrees. It is not going to go up more. Until all that water is gone, that water is going to stay at 100 degrees. Once all of the water reaches 100 degrees Celsius, then we have the temperature of the water molecules keep going up and up and up and up and up. Okay, so again, we start off as a solid. We go to a liquid, right? To go from solid to liquid, that's called melting. That happens at 0 degrees Celsius. Then, once all those forces are broken down and there's no more ice, it goes to a liquid. The liquid keeps heating up until it reaches 100 degrees Celsius. That's when the liquid starts to break their forces and turn into a gas. But remember, it doesn't officially go higher than 100 degrees Celsius of pure water until all of the water molecules have reached 100 degrees Celsius. Okay? And that process is called evaporation. Now, you could also look at these heating curves going backwards. Okay? So, because not only can we change phases from heating up, we could change phases by cooling down. Because remember, a phase change is a change in the state of matter by adding or removing heat. Okay? Now, let's say we start off as a gas. Once gas cools off enough to 100 degrees Celsius, that gas is going to start a phase change going back to a liquid. Okay? So again, this flat spot right here is extremely important, right? We're going from a gas to a liquid. Once all the gas molecules, right, once they start turning back to liquid, we call that phase change condensation. And we experience that every day, right? We open a ice cold can of soda and there's little water droplets forming. That's because the water vapor in the air is cooling down and turning back to a liquid. Okay? Now you might be thinking, well, you know, it's not 100 degrees Celsius when I'm cracking my cold soda open. Why is it still condensation? We're going to talk about that, right? We're going to talk about how water doesn't have to be boiling hot in order to be a gas, but that's later. We have condensation, gas to liquid. At 100 degrees, it starts to change back. Once it gets cooler than 100 degrees, we're back to a liquid. Liquid. We're cooling. Then we get to the special number of 0 degrees Celsius. Okay? This flat line is going to be crucial for us again because that's telling us there's a phase change. Instead of melting, we're going from a liquid to a solid. So that liquid turning into a solid, we call that process freezing. Okay? And then for water, we have ice. Now we're probably thinking freezing must be cold, but not necessarily. Okay? It depends on the substance. So remember, this is our heat curve of water. So I want to make this clear. Heat curve of water. Okay? But we have solids all around us. Okay? The plastic that you have watching this video on your Chromebooks, That's a solid. So at what point is liquid plastic, but it turned into a solid, so it technically froze. So your Chromebook, your plastic in your Chromebook is frozen, right? But it's not necessarily cold, right? We are thinking of freezing, of being ice cold water. In water's particular case, yes, frozen water is cold. But I want you guys to understand that not everything has to be cold in order for it to be frozen.